All right, let's get started. This is recorded. Everyone knows that. I'm going to share my screen and we're going to jump right in. And please, anyone else on, you feel free to come off camera, especially if you have questions and stuff. You can raise your hand. I can see you. We can talk. All right, share my screen. All right. Can everyone see this? And we're going to just to bear with all the ding dongs, unfortunately.
We could see it,
Okay,
Greg.
cool, great. Welcome, everyone. This is the first lightning lesson in a little series. As a brief introduction, my name is Greg Ceccarelli. Some of you probably don't know me, although I see some friendly faces on here. I am a co-founder at SpecStory, and we are producing a course on agentic engineering. Now, why might that be interesting? Why is that important? Why are we even doing this? Reference SpecStory is a startup, and we have a number of products in market. They help you basically take all of your agentic coding sessions, store them, search them, analyze them, share them with your team, and they work with pretty much every coding agent on the market. One of the things as we've been building our products that I've really thought about is kind of like the high skill ceiling that agentic engineering really has and takes. And as we've built most of our products almost completely agentically, there have been a huge number of heuristics that have kind of become patterns that have shaped the way that we ship. And we thought, what better way than to sort of codify those things into an actual course? Because the field is obviously super new. There's a ton of material kind of coming on market every day, but I don't think there's that many teams that have been shipping completely agentically. And it just so happens that it's something that we're all very, very passionate about. So I hope from this lightning lesson, you learn something, at least one thing, and it might pique your interest into going a little bit deeper. So let's just jump in. So the hook. If you've used coding agents for a while, you might think that when the coding agent actually stops, it's because it's done, right? That's an obvious sort of natural thought. But actually, whenever you look into the internals of coding agents or harnesses, and I'll probably use those words interchangeably, um, they actually stop because the coding agent is stopped calling tools. And if you look at the source code of a very popular harness, in this case, this is an example pulled out of the source code from Codex, you can actually see the code that basically says, does it need a follow-up? And if the LLM doesn't produce a need for another cool tool call, then the harness breaks the loop and the message ends. I thought this was like really interesting because I've been using these products for a long time. And whenever you look across the board, you could go and look at the Pi harness, for example. It works the same way. And when you know this, and then you sort of understand the differences between the frontier models, and some of them are more apt. The harnesses that they're in all differ. There's sort of variations in the tools that are even provided to agents. You start to ask yourself, well, how do I know like the work if it's really done? And so that's actually the premise of this entire lightning lesson. It's about creating some determinism where most of what you're actually experiencing is non-deterministic. Now, granted, it's very advanced. And so the takeaway from this, if you listen to no more of this lightning lesson, or you have to go, or you want the gist, is that I think that if you want to become a very good agentic engineer and you want to ship reliably working software that you can trust, you need more guardrails than just trusting the green check mark. And so, what we're going to do today, in a nutshell, is we are going to talk about, again, how the harnesses decide to stop. We're going to take and transfer some lessons from Agile teams, and then we're going to put it into practice. And you're going to see in a very small code example how you can actually create a deterministic check to wrap another harness to make it keep working until it passes that check. So the nutshell version of this is um, you know, if you want to ship reliably, it's good to have a harness that you can trust, and it's really helpful to have deterministic checks that you can verify because whenever you're briefing agents and steering them interactively, the main job ultimately becomes verification. Now, this isn't always appropriate, so at the end, we're going to talk about when you might not want to use this. But that's really it in a nutshell. So as I get into the detail, know that all of these slides, just so everyone knows, I'm gonna paste it in the chat. They're all in a GitHub repo, as is all the code, so that everyone has access to that if you want to follow along on your own. Let me paste this into the chat. So you can follow on by yourself. You can look at this GitHub repo as well. And let's get going. Okay. So this is probably a little bit of a primer that not everyone needs, but I figured if someone was coming in fresh, it would be helpful. So this is Agent 101. I already said harness, I already said coding agent, but the easiest way to think about them is, take the LLM conversation and give it hands or give it tools. That's really all a harness is. It's a wrapper for an LLM that has access to a file system in your environment. The two most popular ones these days are Claude Code and Codex. You run them in your terminal. I'm assuming pretty much everyone on this call has some exposure to them. And, you know, all that happens whenever you invoke a terminal coding agent like Claude Code or Codex, and you give it a prompt, is it sends that prompt to the reasoning engine, the model, and it returns a response, and those responses can be either words, right? Or they can be tool commands, a bash command, search for something, grep for something, right? Run a program, operate something. So that's sort of it. You've probably seen this at least 1,000 times by now. You say, hey, add this health Z endpoint to your app, and you're going to see a stream of tool calls, starting with reads of, the context in your repo to edits to then probably some execution commands, right? And you know that at the end of a conversation turn, there is always sort of like a summary. The agent responds and says, hey, I've done X, Y, and Z. But if you've been paying attention just a little bit, what you should know is that's because it's just run out of steam and decided that there's nothing else to call in terms of what it thinks done means. So it's going to matter a lot. This is basically the same thing I just said in a little bit of pictures, right? And just for a little bit of extra context. We've all seen these. I'm assuming if I could see you on this call by raise of hands, like who's used all of these products before? Has anyone not used any of these? Because that would be surprising. Some people have used them. Nate's used them. Good. All right. So again, putting it in pictures, you provide a prompt, the model reasons about things, the harness that has control and access to tools is observing and acting and calling. And then at some point, there's a reply that doesn't have a tool call, and this run stops, right? They all operate like this, and whenever the tool call is done, the sort of turn completes. And so if you've built anything substantially with any of the coding agents, you know that probably as the harnesses and also the models have improved, this feeling of like, did it miss anything? Is it done? Is there's a number of smells. At least for me, I remember when, early versions of Sonic came out, there were often many smells, right? Everything's passing green check marks and lots of emojis, right? Even though you don't even have tests in your repository. Sort of like, yeah, I've made this modification. If you read back up in the actual conversation, and it turns out I deleted some of your code to complete this objective function, right? There's like scope trimming. And then, of course, depending on the type of model that you're using and the age of it, there's either a very easy to comprehend summary or it's very dense and challenging to get through. And so, as an operator of a coding agent, the thing that I've thought about a lot is like, how can I trust this thing? I find myself often, if I'm not using a product that I'm going to talk about in a second, I always want to like adversarially judge like what happened, right? Especially at the rate that you can produce product these days. And so, one method, one early heuristic from, some of the builds that we've been doing at SpecStory was, if I was using Claude Code as my main driver or planner, I would often have another model like, Codex, ChatGPT 5.5 or now 5.6 actually sort of verify the change set. So if I was producing a bunch of commits, I'd say, hey, like based on the plan that we executed in this session, in this commit SHA range, did we miss anything? Like, did we actually do the work and, expound on the reliability, scalability, maintainability of the actual implementation? Basically a code review. And 9 times out of 10, the adversarial review would find a lot wrong. And so this is kind of what prompted me to get a little bit more specific and start to think more deeply about this problem. Because if I had to summarize, at least for me, what my day often feels like, it's like babysitting models and wondering, after a 25-minute run, sometimes much, much longer, like, is it done? Like, did it actually do the thing? And of course, there's lots of different tricks and tips and hacks, right? You can create, large checklists and tasks. And we're going to talk about slash goals in a second here. But up until very recently, it's been a feeling, right? And that feeling sometimes is a good feeling and sometimes it's not, because then whenever you go to actually sort of verify, whatever it is you've implemented, whether it be a feature or product or whatnot, you're the one trying to piece together, like, why doesn't it work this way? Oh, it's because I stubbed this part of the functionality and I sort of hit it in my response and I didn't really tell you. Okay. Before we get into the actual like demo and the harness and everything that I want to sort of expose, I think take a step back. This concept of definition of done, it has a human origin. At SpecStory, we're not like a big Scrum Agile shop or anything, but I actually think a lot of what Scrum and Agile did in the mid 2000s transfers super nicely to the way that if you're operating agents every day, you should be thinking. And so, when it comes to what a Scrum increment is, often if you're sort of operating by the book, there's this concept of a program increment, and pretty much every program, sorry, every increment to be sort of considered like ready for the sprint has to have two things: a definition of ready, which is like the requirements for what you're going to implement, and then a definition of done. The definition of done, the 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 reason why this transfers, I think, really nicely to agents is, you know, typically it's something that is shared by everyone, and it sort of is something that you need to conform to ensure that, that piece of work, that body of work is actually done, ready for review, ready for QA, ready for production, whatever it is that matters to you. And so I sort of lifted that concept because in a lot of cases, the kinds of done checks that you can deterministically write can go beyond like acceptance criteria, right? They can be universal. They can be something that is going to apply to every single thing that you do on a project. But they can also be acceptance criteria. And so I'm sort of using this terminology loosely. All right. So again, the reason why it sort of worked is because these checks, these definitions were written before the work started. This is like really important. And it it's the same if you're doing it deterministically or if you're using like an LLM as a judge. There's a checklist, right? It's not like a vibe. It should pass these things. And it's sort of binary, right? It's you're not 90% done. You're like either done or you're not. And it's shared. So, you know, there's a definition of done for humans that like to fool themselves. And, for us working with agents, because they can fool themselves very quickly, there's now one too. All right. So I think there's a little bit more preamble before we get into the fun stuff, and that's the model companies, the frontier labs, have been thinking about this as well. I can't see everyone, but by a show of hands, who's used the goal functionality in Codex or Claude Code or another harness of your choice? Okay. Awesome. Well, I was like super intrigued when this came out, because a lot of people, if you sort of rewind time a little bit, had been kind of attempting to create their own goal loops themselves. If anyone by show of hands too has ever heard of like Ralph Wiggum, in a sense, that's like a goal loop, a very sort of dumb heuristic, but it's like, keep the model going for, you know, 20 repetitions or 20 iterations, right? And it's been really nice to see, Anthropic and OpenAI add these to their harnesses, but I think there's still like a lot of mystery as to how to like create goals that are actually going to create long unattended runs. That's also something that, towards the end of this, we're going to talk about more deeply, but being able to stand up, walk away, let your sort of agent chug for, you know, an hour, 2, 3, 4 hours, depending on the complexity of the task, is kind of the reason why you want to be able to use, a definition of done, constraints and variants, things that are going to keep the harness working. And so when this first came out, the goal implementation in both uh, Codex and Claude Code, I wrote a little, I don't know, it's not really little. I wrote a brief on it, and so you can find that here at Goal Engineering, and it has a skill that I use today to actually create my goals. A couple little bits about that. If you go here, it's gregciccarelli.com and then goal-engineering. And the best bit is probably the skill at the very bottom, that you could download and use. Couple quick bits. First, when you write these goals, they're capped. I like to write a goal that has a single theme. I always sort of have like a posture in my goal. And, often it's going to have effectively a definition of done in it. But again, these aren't deterministic checks for the most part. In some cases, if you have a good build pipeline, they can be. But it's not exactly the same as I'm going to show you. So I would encourage everyone to check this out. If you haven't used the slash goal command, you really should. Again, there's not like a right or wrong way to use it, but if you want to see like a lot of examples, I'll share at the end a repo that I've used to create a harness that we're going to talk about that I've done completely via goal engineering. So almost 100,000 lines of Rust for this harness that wraps other harnesses has been done using the patterns that I wrote about in this goal engineering essay. Okay, so quick overview of the difference between slash goal and the sort of checks you're going to see. So again, like the thing that I don't like about slash goal is that the underlying model provider and another model, whether it be, like a sibling model run by sub agents or similar, is actually the thing that decides if the loop is over, right? And that's convenient because it's all baked in. But if you want, you know, to do a very long run, it's similar to like how coding agents actually stop. At some point, that loop's going to end whenever, no more tool calls happen and the sort of judging or adjudicating process is over. So that's why I'm also a fan of deterministic checks. And this is the core of building a definition of done for a coding agent. So, what I mean by that, and we're going to get into it here, is writing something that will control your harness that can be verified outside of the harness by a separate process that will control when the loop ends. And if you think about it, depending on what you're programming, what you're doing, these can be arbitrarily complex or very simple. But this is what I'm sort of surprised, and I wouldn't be surprised if sort of the course tune changed. A lot of the actual harnesses today have not yet incorporated. So, because we have the power of agentic coding, we can build one ourselves. So, the whole lesson, all this preamble, can be summarized into this one slide, right? You define deterministic definition of done checks, and then you have a loop effectively that will run those checks over top of the harness that you use to do your primary implementation until it satisfied them. So in this case, this is like extremely simple and it's not um, it's not the fun stuff. This is like doing stuff that the agents will do themselves. But just to sort of make it crystal clear, you have, in this case, there's like a shell script. You have an example of, what has to be completed before the loop's allowed to end. And then you have a loop that's actually running it against a non-interactive invocation of your harness. And we're going to see it in a second here. But that's the concept. And you can take this and expand this and make it, very complex. That's what this separate open source project that I've been working on called Dead Reckon does. But to drive home the point, we're going to get into the demo. So what the demo is going to do is it's going to run two different invocations of Claude Code, and it's going to loop through a very similar setup such that one Claude Code will like just stop, and the other one will attempt to stop, and then it will get re-kicked off again based on some requirements that I've given it, which I'm going to show you in a second. So this is like just so you're tracking, you're going to see a bunch of tool calls. You're going to see in like a tmux terminal session, both Claude codes running, and then you're going to see one of them stop. All right. So in this repo, and again, this code is in that GitHub repo that I shared. And so I'm in the Lightning Lessons definition of done folder and then DoD demo. So you can run this yourself if you have Claude Code on your desktop. And this is the README. So we're going to invoke this shell script, and what it's going to do again is run Claude in both panes. Now the important part here is this sort of gate. When this shell script runs Claude Code, it's going to do it in a temp directory so that Claude Code can't see this gate. And this, in my case, is my definition of done. It's a very simple check. What you're going to see is Claude Code's going to be given a prompt to create a slugify function. Basically, take a string and turn it into a URL slug, right? But what one of the Claude codes doesn't know is that there's a test case. Again, this is very simplified, where if there's an ampersand in a string, then it needs to actually convert that to an and that's going to be where the failure mode happens. So I'm going to make this bigger. Hopefully everyone can see this. And I'm going to kick it off and let's see. Hope it works. So again, this is orchestrating two Claude Code sessions. The turns will come in sort of like non-deterministically. On the right is the one that actually has a gate, a definition of done associated with it. The other one is just a pure vanilla Claude Code session. Okay, you can see it's happening. So in this case, this one wrote the slugify function and it just stopped. Around the same time, this one also did, but the gate, that loop that has that check in it, kicked the session back off and said, no, 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 you didn't actually implement this correctly because it didn't pass that test case in this simplified example. And so it kicked it back off and it looped again. So this is the concept very simply. I'm going to stop actually for a second before I keep going to see if there's any questions or any comments or, hey, that's interesting, tell me more. So please, chat. Anyone has anything on their mind, let me know.
There's a question, Greg, in the chat from Rahul. Doesn't Goal have dynamic workflows with deterministic workflows?
Um, so I don't think Codex does, but Claude Code has a slash workflows function, and the workflows themselves are deterministic in terms of running. But I think that there is a difference between what I'm saying here in terms of you could hypothetically use a workflow, a dynamic workflow, to do something to continue a loop, but the model is still operating all of that, and it has access to everything in terms of the check. So it could forge it. Now, a little bit of foreshadowing. Um, I think the thing that makes this important, and in this trivial example, it's probably not coming through super well, is that if you want to really make this sort of airtight, the model shouldn't or like should be like physically unable to see what the check is until the check is run. And so that's a principle in my dead reckon harness, whereby when you run that against your coding agents, it actually sandboxes the runs and it has the all of the checks completely hidden until they're called to be evaluated. And we're actually going to talk about that exact sort of nuance in a second, because that's why this trivial example falls down. And you wouldn't use this like in production or for real use cases. It's just kind of showing you the premise in action. Um, so you're not wrong, Rahul. They do have dynamic workflows. Uh, and those workflows can be made deterministic, but unless you make that workflow adjudicate a run, it's not exactly the same. Now, whenever you use a workflow, if you've used them, and I love them, um, they do often have like an adjudicator step in them if you actually look at your workflow. Uh, but it's you haven't probably written a different definition of done up front. Hopefully that answered your comment slash question. Feel free to elaborate or ask me a follow-up.
Thumbs up. And then Brian has a little tongue-in-cheek comment. Did Greg make a secret hidden objective function?
Oh,
Uh,
it was secret in this one. For sure, for sure. Okay. So we get this exit code and the loop terminates. Awesome. Okay. So this is kind of exactly what we are just talking about. Like this very small code example has lots of blind spots. Like, there's no feedback being given to the model. It just knows that it like didn't pass the check. It could technically like keep retrying if you don't have sort of an exit condition, sort of like an escape hatch, right? And if your, model has access to this context, it could and probably would at some point attempt to modify the check to sort of be able to complete. And so, there's a lot of things that you could do to like that simple example script that I was showing uh, to solve for some of these things. And there's obviously a lot of things that you can do if you really want to take this seriously or one step further than just running a bunch of shell scripts, which I wouldn't recommend, but they're useful for demoware. So this is the sort of brief introduction to a little passion project of mine. In a lot of ways, it sort of codifies most of the heuristics that honestly I just found myself doing over and over and over and over again, using the sort of harnesses in like a vanilla way. So again, that sort of core nuance, and to Brian's comment, it's like you need to keep the thing that actually verifies the run sort of segregated. It should be in a separate environment that the model or the sort of runtime environment doesn't have access to. And so this DR gate, that just like dead reckon gate in this project's sort of parlance, whenever there's a dead reckon run, which you can go to deadreckon.sh and you can use this if you want, you can read about it, you can look at the source code, you can fork it, have at it. When dead reckon runs one of your harnesses, what it does is it sandboxes that run, uses work trees, but it also sandboxes it. And then the process that's the deterministic check, I'll scroll down here a little bit, sort of sits outside of the process where the agent is operating. And it's defined up front before you even generate a run. And that generation of your definition of done criteria is compiled into like a deterministic set of checks that could be verified. And that's what actually is kind of preserving the sanctity of knowing that your sort of run finished as you thought it would. All right, keep going. Yeah, this is kind of reiteration, and sort of why I think this is maybe a better approach. The other thing too is there's a lot of sort of techniques I kind of talked about a little bit that I wanted to bake into something that was, more industrial strength. So for example, and I'm sure a lot of people have sort of done this themselves, like I mentioned that sort of one planner implementer agent sort of concept, one sort of, reviewer agent concept. I baked that in so you can mix and match the harnesses that you're orchestrating with Dead Reckon. I think that's probably the most useful bit because instead of going from sort of one interactive session to another and saying, hey, look at this commit SHA range and evaluate this plan, you can just have the reviewer agent built in. You can orchestrate like a much larger job across many different coding agents. But the core of it is, hey, I want to write the reason or a set of reasons as to why this sort of loop should end up front. I want them compiled deterministically, and then I want some other process outside of the model's runtime to be able to actually verify that it worked. All right. This is kind of instead of going through the whole dead reckon kickoff workflow, it's meant for long unattended runs, so like would not complete in the time we have. This is kind of like what it looks like in like pseudocode. So there's a bunch of commands. The easiest way to get started is to do dead reckon start once you've like installed it and configured it. But you write something like, hey, these are the criteria that I want to be compiled into checks. It'll actually compile those for you. And those checks are things that you can read, verify. They're sort of like in your repo. And then whenever you kick off your goal, that's what's going to actually end the loop. So I intimated at the start, like there's a reason to do this, and there's a lot of reasons not to. And I can't say that I only operate this way. There's been plenty of code shipped in a way completely dissimilar from what I just described. But there are cases where, there's a large amount of work that I want to get done, and I don't even, my heart of hearts, like I love using dangerously skip permissions. I love the new auto mode, but if you've used those sort of pieces of functionality, you know that there's still built-in guardrails to the frontier models that will actually prompt you for action no matter what you do. And I've seen it happen in dangerously skip permissions, and I've seen it happen in YOLO mode. And so I think, if you're going to sit there and you want to have an interactive conversation, which I think is actually very useful coding agents, I don't think that you need to take all of this to heart and build these deterministic checks up front. I do think that it's very helpful if you wanted to kick off a long run, walk away for 3 hours, and come back and know that like there wasn't a premature stoppage. I also think it's very helpful just from a mindset perspective, uh, forcing yourself to think about like, what is the criteria that, this sort of piece of functionality needs to satisfy is just a great, product behavior in general, because it's a form of a requirement that's very, very easy to sort of sidestep, right? Because everyone is, I think, so entranced and get so much dopamine from seeing, the models do what they do and seeing the code sort of the patches light up and, being able to kind of be there in front of the thing. But it's not appropriate for everything. So I think, again, maybe there's more cases I haven't thought of. People on this call might have, different perception or ideas, but I think it is a little bit like test-driven development, but these don't need to be pure tests. I know some of the examples like seemed like tests. I'll give you one anecdote. As I've been building Dead Reckon, this harness for other harnesses, I've been messing around with a bunch of different examples whereby I give, just a vanilla Claude Code or Codex session, a prompt that's more than a prompt. It's like effectively a large spec. And then I've been giving Dead Reckon it to understand, basically to eval it. And there was one example where I was making this sort of space playing, like sort of space shooter game. And one of my definition of done checks was that the sort of product needed to be publicly deployed and played. And I remember I told Jake and Sean on this call that I was so amused by like the effectiveness of this DR gate process, because when I came back after like an hour and a half, I found out by looking at the logs that um, I think it was Claude Code being wrapped by Dead Reckon. It had actually found credentials on my machine for Vercel and decided that the only way that it could verify this check was to actually deploy without my authorization, like all of the code, to Vercel, and then pulled up Playwright and it was, screenshotting it and it was playing it because this was like a network game. And I was like, wow, this is something. Uh, Now, I wouldn't recommend like giving that kind of definition of done, but I wanted to sort of see like, would it actually do that? The other Claude Code session, because I normally do this in parallel, where I basically do the same thing under different conditions, did not go that far, even though I'd sort of given it similar prompt criteria around, making sure that it was publicly playable from something that wasn't localhost, right? So that's the power and maybe perhaps the danger, depending on, the criteria you give your models. All right, I'll stop for a second. I see some chat stuff. Oh,
That was just me.
okay. Oops. Okay. So plenty of time to skip ceremony. Just a brief recap, right? Um, harnesses normally stop because the model stops calling tools. It's a feeling, not a fact. There's a lot to learn from human behavior. Scrum's definition of done, right? Your sort of criteria first. There's a checklist shared. It's binary. It passes or not. Great transfer for coding agents. I love the /goal command, but do know that there is still a lot of non-determinism in it whenever you run it, although it works exceptionally well. And make sure that if you implemented from something from scratch like this, or you're interested in doing it, that there's evidence, right? I think that's one of the most important things as we sort of become more verifiers than implementers, is not only storing and tracking the sort of evidence of runs, but codifying it into a way that someone could go back and say, oh, I see how this sort of run that was very long actually progressed, and I can recall that evidence. Because if you're just using the harnesses in this sort of vanilla form, if you like lose a session or start over, like while those chat transcripts are there, maybe thank you SpecStory, like there's a lot to parse through. And so it's nice if, some of that evidence can be made more compact for you and you don't have to kind of parse all the agent reply output to understand like, did this thing actually work the way I intended? And then, of course, not appropriate for everything. That's the standard disclaimer, right? Great if you want to get up, go for a walk, maybe run something overnight and come back to something to review. Not great for interactive coding. So tonight, I think even if you're not completely sold, when you get your hands dirty, you can use some of that code and you can run it from the repo just to see how it works. You can modify it. You could make the example larger. And then of course, if you want to try something a little bit more industrial grade, I'd urge you to check out the Dead Reckon harness. It's actually a pattern in sort of a model for what the hardcore agentic engineering course is going to be all about. So if you're interested in that course, that's a little bit of a preview because over 3 weeks, we're going to get way more into the internals of doing this for real and building a very similar harness that, you'll be able to customize to your liking. Because I think beyond what I said about, making sure that you can verify with evidence, there's a lot of other quality of life behavior that you don't get like out of the box whenever you're driving coding agents all the time. So things like a narration of what happened, right? Like turn by turn logs that you could go back and resume from. Like all those things aren't kind of completely baked in, and especially not if you're using a lot of heterogeneous model providers and tools. I know a lot of people, a lot of my workflow has changed whereby I'm hopping from one harness, one model to another every day across many, many projects. So thinking about this sort of from first principles, but also from heuristic patterns, and then codifying it into the sort of runtime for your harness is, I think, really important because you're going to learn a lot about how these things work, but you're also going to be able to use the models much, much more effectively. So, last sort of call, shout out before we turn it over for any types of questions. Uh, Before the course in August, there's two more lessons that I have lined up. Next Monday, I'm going to have my friend John Berryman on, and he's going to talk about building an environment aware agent. It's something we've both actually been sort of hacking on. Him a little bit more full time than me, but the premise of that talk, if you're interested, is imagine if you could have a personal agent on both your laptop and your phone that whenever it was in the foreground, it could see the running process on your phone or on your computer, and it could dynamically load context in. So, as an example, let's say you have Obsidian open on your laptop, right? You have this thing, it's called Rook, open too, and it sees Obsidian in the foreground, and it has a bunch of custom skills that it loads about Obsidian. And it's like instead of having to load all the context from scratch through ACP and through sort of a custom skills format, it would have access to that. If you go to Wikipedia, it's going to have a skill for Wikipedia and it's going to know that you are there. So we're going to get into the internals of that. I think it should be really fun, exciting. And then 2 Mondays from now, right before the course starts, a friend of mine named Dan, he hosts a great podcast called Agents and Engineers, is going to talk all about like the sort of personal rig setup for being effective at agentic engineering. So you should be able to see all of these from sort of like the SpecStory Maven course page, and there's links for all of them in this repo as well. And whenever the slides are ready, we'll put them here, and you can get to the registration pages just directly from these links. And then the recordings will follow as well.
Hey,
All
Greg,
right.
there's a question in the chat.
Oh, sure.
Yeah, Sergey asked, hey, Sergey, how do you envision this approach used within a team setup where we still have traditional devs and PMs? some of these exit criteria can be very technical. Did the tests really pass versus some product outcomes? Is this a fully collaborative framework, i.e., no single owner?
Great question.
Yeah, it's a great question. I think about it right now more from an inner loop perspective. So if you're familiar with like the difference between inner loop and outer loop in programming, like historically the inner loop has been like literally like dev gets requirement, codes, commits, does local tests, opens a PR, and then that's kind of like the start of the outer loop where it becomes more collaborative. But that is a great thing to think about because I know teams today and like even ourselves, we tend to work in a fairly trunk-driven manner at SpecStory. We don't open a ton of PRs. We have PRs process that gets us from dev to production, and obviously hot fixes and things like that. We'll work on branches and PRs, but a lot of constant integration into mostly like a single trunk. One of the things that I know a lot of teams do is have sort of like shared Claude MDs or agents MDs that have conventions. And sometimes those conventions might enforce things through maybe a pre-commit hook, post-commit hook, that type of thing. But right now, just to be very explicit, like this isn't geared strictly for collaboration, meaning this isn't, I haven't thought of it from a collaborative approach, but it's certainly something that could be very appealing. You just kind of have to have more people leveraging this other harness of harnesses, but it's a great call out.
Cool. Thank you, Greg. Jake
Yeah.
and I used to work together, so we talked a lot about collaboration in the past. That's why I'm curious.
Yeah. 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 So yeah, that is pretty much the conclusion. I'll put the recording in the repo. You can find this deck and demo code, everything there as well. If you want to check out Dead Reckon, please do. And then of course, I would be remiss if I didn't plug SpecStory. If you're using any coding agent and you want to retain all of those precious chat logs, you know the open source tool and product to use. So I'm going to stop sharing at this point, and if anyone wants to ask another question, a different question, say hi, please feel free. Anything else?
Ooh, here's one. Have you tried mapping sagas? Rahul has a LinkedIn post on his attempt, but have you tried mapping sagas?
What do you mean by saga, Rahul? Are you talking about something that's like bigger than an epic of work, or like just tell me what you mean by that word?
Yeah, in distributed systems, you have a concept of a saga, wherein in a single system, in case you have a database and you have a transaction, you can roll back the transaction as if nothing happened. But in a distributed system, you can't do that. If one step was send an email, then you can't undo it by anything. You have to send another mail saying, sorry, we sent that, or in case you had paid somebody, you need to issue a refund. That's called a compensating action. So my exploration in mapping sagas to SDLC was if my agent goes haywire, can I compensate that as part of a saga pattern? So have you gone down those lines?
I can't say I have with this.
Yeah.
No. Yeah, I mean, yeah,
Yeah.
this is more like, yeah, like inner loop code production, right? And making sure that it sort of meets your requirements by finding things up front. But that's an interesting idea.
Rahul, share your LinkedIn post link.
Yeah, please. I'd love to see it.
Okay. Okay. I'll do that.
The
Yeah,
Brian says,
Betty Ann. I got you, Betty Ann. So if you go to this GitHub repo and you just scroll down to the lightning lesson section, These are all just free sort of talks before we actually have a 3-week course that's like very hands-on that starts August 3rd. But you should be able to find the sign up links there. And then however you got to this sign up link, if you still have that address, which is in the README, it should have sort of like a cross linking on Maven.
Okay, thank you. I know that I was able to find this through John, and I've signed up for this and John's talk next Monday,
Great.
but I didn't know about the third one, so I'll find it. I'm sure, I guess if I click around a bunch, I'll find it.
Yeah, here, I got it for you. This is the direct link. There you go.
Thank you so much.
Yeah, no worries. Cool.
Also, by the way, great talk, really nice. Thank you.
Thanks. I'm glad you enjoyed it. It's funny, like, as John and I were thinking about what talk to do, I know that this particular talk is kind of dry, but I actually think it's one of the most important things to try and get right, because if you are like me and you're spending hours, untold hours, like watching your coding agents work and then trying to figure out like how to verify what they did, anything to sort of reduce that pain, which feels like Groundhog's Day once you've done it for as many months or years now as like we've been doing it, is like the most important thing to get right. So while it's not as intriguing as building something like an environment aware agent or other sort of sexy topics out there, that's not really the point, right? This is about like, what is it going to take to be able to do this reliably over time and ship software that you can kind of trust? And so that is really the whole premise of the Hardcore Agentic Engineering course, and why this sort of little teaser lightning lesson was about that topic. Because if you look at the book on the 25 patterns in agentic engineering that we put out, one of the first section is called verification is the job. And that is more and more what we find ourselves doing, is verifying, is this right? Is this like, does it match my intent? And it is something that, of course, every harness is going to get better and better about, but the more you know about how it works and what you can do to augment, complement, decorate what exists, the better and sort of, I think, more confident you'll be in agentic engineering.
I could not agree with you more. I mean, I spend almost all my time now after writing specs of trying to verify, and it just gets old.
Yeah.
So thank you for this nuts and bolts look at it.
Yeah, absolutely.
Thank you for putting it so frankly and clearly as well. It does get old.
Yeah, it totally gets old.
Yeah. All right. Any more questions, or we can wrap up? It can be about anything at all.
Are you really open to anything at all?
Well, sure.
Well, I'll pause and see if anybody else really does have any questions. And if they don't, then I do have like a question or a comment.
I'm scared for you, Greg.
No, actually, it's really just, it's kind of specific to me. So that's why I don't want to take up everybody's time.
I think the floor is open.
Yeah, it's open. If anyone needs to drop, feel free, or you can hang on for a little bit more.
So here's kind of my premise is, so far, I'm thinking about what you just shared with us along the lines of, I have something in production and I want to be sure it completes properly. What I've been spending my weeks, like the last 6 months almost, is writing brand new stuff where I'm speccing a feature out and then I'm saying, okay, let's develop this. And the feature I spec out all the way down to like individual phases. Within each phase, I have steps. And what I'm doing now is I'm like, okay, Claude, implement this phase. And then when it's done, I ask it to write tests, but I still don't trust it, right back to it's done, but is it really? Did it finish? Did it do what I wanted? So after every phase, I literally check things, and it's very tedious. What I'd like to be able to do is feel with confidence that I can say, here's this ticket and it's got 5 phases in it. Go ahead, do this. And like, I want to know at the end, yeah, this is right, as opposed to me babysitting it. And that's something you said in the beginning.
Yeah, so I feel like you just kind of confirmed the need for a more deterministic process.
Right, exactly. That's why this was such a great talk for me. But
Okay.
I think the thing that's not clicking for me yet is I don't yet see how this is gonna work for me as I'm like, I don't know, either doing boutique personal projects or I maybe the problem is I'm hedging on what done is. Maybe that's really what it comes down to. But I feel as if by having a back and forth conversation after each phase with helps me, Claude helps me think about things I didn't think of in the first place. So if we just went with my original plan, although I guess it's in the planning stages that maybe I can still have that back and forth.
Yeah, totally. I mean, so one of the nice things about like goal engineering, which is like clearly a very close sibling to writing like more deterministic checks,
Mhm.
is that actually let me pull up the exact place where all of these are because I think it's like sort of helpful to see this. So in the dead reckon repo, if you look at docs, I'm gonna send the link in a second here. Um, all right. I just sent a link
Yeah.
to the
Thank you.
docs goals. These are all my goal and rider pairs for producing this monstrosity. Um, One of the things that I like to do that might help you, and again, it really depends, on your requirements, is I like to keep like some of the goals that I write like kind of open because like if you think about it, like one of the benefits of using a coding model, although it's also like a little bit of a curse, is that you do get to delegate some of the decision making, right?
Mhm.
And so if you're trying to specify like every single thing, I think the thing that you miss out on is kind of the sort of serendipity of discovery if you let your requirements sort of be open a little bit to interpretation. Now,
Yeah,
it
I
depends
agree.
on what you're doing, right? Like if you're writing some high performance code for something that needs to be optimized, like right, like you're gonna have more exacting requirements than if you're building like a CRUD web app. Um, but if you sort of like leave your goals and this concept of a writer is just extra context that the model will read whenever it invokes the goal, kind of open. Um, I'm a fan of doing that often because I don't want to be always so exacting in the implementation steps. I'd rather sort of control the shape of the sort of outcome and what qualifies as sort of good or bad, right?
Yes,
And
yes,
then
exactly.
after that, pair back or pair off things that I don't like or I didn't pre-specify. And so I guess like one of the ways that might shape your behavior or the way that you work, because I found this in myself, is I'll often give like a pretty lofty, you know, like goal to the agent for whatever it is I'm doing, and I'll let it run for a while. And then what I find myself doing is instead of spending all that time in the past up front, like trying to plan out things super, super meticulously into phases, I'll go and, edit and basically cut things out or change things after, a lot of code has been produced. And I don't know if it will work 100% in your case, Betty Ann, but um, I think that approach has been a little bit freeing. I've talked to Jake about this before. I've likened it to being kind of like a sculptor, right? Like, imagine you have a big block of marble, right? And you know what the David looks like, right? Um, and
Yep.
so you start to sort of like form the rough shape of a human, and like that's going to get you, 80, 90% of the way there. And then whenever like that human shape is there, you go and you chisel out, like the musculature and the veins in the hand and the shoulders, right? And that's how I like to use agents these days because I think a lot of people don't don't give their agents big enough, lofty enough uh, units of work to do, right? You're not going to get the leverage. At
Yeah,
least I don't think you get the
that's
leverage.
exactly where I think I am, is where I feel like on some level I'm micromanaging and what I'm doing is inadvertently limiting the model. I mean, the reason I want the model is because it can know quote unquote see more than I can. And what you just mentioned, Greg, is something I have been sneaking up to, but haven't committed to yet, which is go ahead, let the model make a whole bunch of mistakes. Go ahead. I mean, that's okay. In the olden days, I wrote code that was crap all the time and I had to redo it. So why wouldn't I give the model the same grace to make mistakes? Or write a bunch of stuff that I'm going to throw on the cutting room floor.
Yeah, and plus, I mean, maybe the main benefit of the approach that we're sort of conversing about here is at least you end up batching when you're reviewing, right? Like if you're doing it like every conversation turn, right? You're like, okay, implement this like small piece of code, then you're checking it and like rinse and repeat every single time. Yeah, that I think that becomes like very nauseating, right? And so it's in my view, it's better to sort of scope something up front that's lofty, sort of give it the criteria that you want it to stay within the bounds of, and then sort of save that review completely mapped to like the criticality of what you're implementing until after. Because it might make some choices that would surprise you or be delightful, right? And
Exactly.
the bigger your sort of ambition with the way that you think about prompting, potentially there's always trade-offs, potentially the sort of like better outcome, at least
Yeah.
in terms of your time.
Yeah. And I guess what I have to get comfortable with is that what feels to me like a big unknown, but that's what models are for, is to do the stuff I don't know.
Yeah, and I think so yes, I agree 100%. I also think that, you know, and I'm sure people on this call and even yourself, like you can ask the model to like explain
Yes.
anything that it
Yes.
does. I'm very much in the habit of that. Like, I have a couple little skills like that I use often, just codifying so effectively prompts about like breaking down and explaining things into diagrams for me, especially data flows and like tracing through different code paths, like
Yeah.
subsystems and stuff. Because the one of the biggest challenges these days is, keeping up or not allowing yourself to get encumbered by cognitive debt. Um,
Yes.
so yeah,
Yeah. Well, thank you so much. And thank you all for indulging me. I appreciate the conversation.
absolutely. And yeah, Brian, you're exactly right.
Yeah.
I agree with the tension. Like that is the tension. And so I think that it gets back to like the criticality of like what you're doing.
Yeah.
So, since you opened the floor for any questions, may I, or if you still
Sure.
have time? So I'm actually not a like a developer or software, just actually a physicist. So I'm coming from a whole different perspective, but I have the same issue, right? Verification, right? Especially if you do it for like something in research, verification becomes a very hard task, right? But in general, I'm also not well versed in the world of LLMs or like the technical details. But I know that um, something like alignment, misalignment, agentic misalignment is still an open problem, right? Like even if the model is very good, it would still derail. Even how good your MDs are, how good your instructions are, how good your goal are, it will still derail. According to research, at least, according to the papers from Anthropic that I looked at, it still does some derailing. So I would need somehow to verify as well. And then coming back to the what she said just now, I tend, especially if you're like, I don't have an output from the code, right? Like I do have some physics at the end I had to verify as well. And then I jump into this overhead of I have to verify almost every step. There's probably a sweet spot that I have to find so I don't create more work than without doing it with the LLM. But I was interested in your input if you know this problem of misalignment. How does it prevent us or like be like a barrier in actually achieving the goal? A, and B, is it actually being solved with time? Like, so is the research and developing an LLM or the agents itself making this problem smaller and smaller? Is it solving it, or is it really a bottleneck in like something very fundamental in the architecture or like the way they train the models?
Yeah, this is
Um, And another maybe stupid question because I just let you answer both of them. When the agent is working, when there's a loop, what do you guys do when when the agents are working? I mean, because there's like I can't start a new project, right? Because I have very little time, so when it stops like this very small loop because I have to verify again. But then I have some dead time actually. This is still an issue. We're still also. I mean, I don't know if you have approaches to solve this already, and maybe I'm just not well informed. But there is
Yeah.
actually some dead time, right? Okay, this is my two questions. Thanks
I
for.
Yeah,
I
and
use my dead time to teach myself to juggle. So see if I
Yeah.
just to chime in really quickly, this also your first question, Ollie, lines up with Dimitri's question about the bottleneck moving to verification. So I'll give it to you, Greg. There's two big
Yeah,
questions,
yeah,
right? The
sure.
verification bottleneck and the what to do with the time.
The second question is, I think I'm better equipped to answer, although I will opine on the first two. The second question about what do you do whenever your coding agent is off to the races, chewing up more tokens than is at all necessary to solve most most jobs. I do think that if you're going to use the like most advanced frontier models that are going to be very token hungry, you probably should work on multiple projects at once of some nature. I don't think that they have to have the same same requirements for focus or cognitive complexity, but if unless you have other hobbies, reading social, reading the news, reading a book, whatever, like there is a lot of downtime, right? If you're working on the same project, I actually think that the sort of most effective way to sort of balance the ping pong is because it is like kind of ping pong between like terminal tabs. I don't know how you have your setup for the physics that you do, but like I like to have one or more planning agents that I can be sort of iterating on plans for and, gathering context about, perhaps that particular repo and system, or from elsewhere doing like research, like maybe internet research or like looking up new libraries or something like that. So I normally have like 3 to 4 terminals running in sort of a plan mode. And then depending on the sort of scale of the code base, I think that you can have different implementation runs because if your code base is well segregated, like, you might not touch something. And so that way you don't even have to really worry about like using work trees or other means because it's just going to be completely separate. Like if you're, front end and back end, right? That's like probably the most prototypical example. Um, but what I do, although I might not be like most people, is I'm often, spinning many different sessions at once across at least 2 to 3 projects at a time. And I think that's not for everyone, but it follows a very similar pattern of, you know, well articulated plans or goals up front, execution runs, research, and then you kind of like get into it. But if I was just like looking at one terminal session or, one IDE session running, like, yeah, I mean, I'd probably lose it. Like, so I need to keep myself occupied. Um,
Yeah, I'm not sure if this is relevant for also most people, but there's a cap here of resources, right? Like, because the agent is using, it turns out the project or the plan is just too many steps, it's chewing a lot of tokens. And then probably, I mean, when I check on it, I kind of see, okay, this problem is hard or like it's struggling a bit. So I know, okay, it's probably going to take all my tokens for the day that at least I'm internally budgeting. So it doesn't make sense to start a new project because then tokens are out, both projects are dead, and they have a lot of dead time. And we back to
that
coding, I guess.
Yeah, that is a constraint. Yeah, depending on, what you're using, what your budget is, that's a constraint that right now, like I don't have to the same effect. I don't know if you like use one of the like effectively all you can eat subscriptions. But I found it very hard to elapse usage windows. I mean, you can easily, depending on what you do, especially the sort of context you can chew through with something like a workflow. Um, but yeah, if you're budget constrained in terms of the tokens that you can use a day, I can understand what you're saying. So in that case, I would probably just scroll Twitter or something, and feel worse than if I had just looked at my
Thanks
coding age.
thanks for relating.
Yeah, I mean, it is interesting, right? Like the more advanced these models get, the more steps they run, the more token context hungry they are, and the longer that they take. So it is a question. Like I don't know what the right answer for it
Yeah,
is.
but it's also
Okay.
not a new question in the sense because it's a resource problem. So before we had time, it's a resource, our time. Now we're just shifting to tokens, and then our time is free, but still the same resource in the sense that it's a
Yeah.
bottleneck, right?
And that's again just like a little bit of a callback. That's kind of the premise behind, all of this definition of done stuff in the first place is kind of being able to like walk away. Being able to get up and like not sit there and necessarily babysit until the end is nice. Or just do something completely different, right? But I see that Betty Ann said the same thing. Like I do think probably the most effective thing is just to like plan like what you're gonna do next because you can batch a bunch of plans, right? And generally, they're not going to be as token hungry as actually like the implementation step on average. All right, the last question you had, or I guess it was your first question on like misalignment. Um, I have zero domain expertise in physics, but I guess where I've seen different levels of misalignment in, not necessarily agents, LLMs that I've used has definitely been in writing. Um, and I think it's really interesting because, I think a lot of people use LLMs for writing these days. Like if you go on LinkedIn, I think something like 60% of it is, Claude slop. Um, but if there's not a objective function that can be sort of like verified with a reinforcement like learning loop, it's an interesting problem that I'm also not super qualified to talk about outside of just kind of what I've experienced myself. But I definitely have experienced different eras and model families when it comes to something where there's not like a right or wrong answer. It's sort of subjective, or there's sort of not an easy way to sort of verify that quote unquote goodness, sort of regressing over time. And what I mean by that is like, I think actually, I don't know if you will remember this, Ali, but one of my favorite models for writing was actually O1. So OpenAI, they had the O1 model. It was like one of their first like really advanced models. And it was aligned well for whatever reason, for like actually writing text. I think at this point, everyone sort of knows the tells, right? It's not X, it's Y. M dashes. My like least favorite now is the insertion of load bearing everywhere. Everything is load bearing, right? It's quietly load bearing. Here's the quiet thing that right? Like these things are now kind of getting, for whatever reason, baked in to the weights. And it's like maddening. Um, so yeah, I don't have an answer, obviously, about alignment, how hard or easy that is going to be able to sort of like solve. I do know, a lot of what the big labs are investing in these days is data labeling, especially in domains where, they don't have a massive corpus of sort of like golden data sets, right? Like obviously coding, has a lot of ways to sort of verify quote unquote correctness. Doesn't mean it's right, but it's like, hey, can we compile this? Can we have this holdout set? We use Sweet Bench, Terminal Bench, all that stuff. If you're working on, I don't know, physics that don't have like an answer, it's like it's unlikely that at least in that domain, there's going to be sort of better alignment than in a domain like code, right? But yeah, I mean, I think that there'd been a lot of talk about sort of small models like purpose built for certain applications. And I'm sure if you go on like Hugging Face or similar, you can find some. I don't have a ton of experience like as a user of very small models because I spend most of my days thinking about either writing stuff or creating like software products. But there might be some answers there. I think it all comes down to effectively understanding that like models are autoregressive next token predictors, right? And so depending on the data set that was used to sort of do the pre-training in the way that they did the post-training in evaluation and reinforcement learning, if that is something that that lab is doing, it's going to, lead to a model that is either extremely well aligned for a particular domain application or probably not so much for others. And I think that's, there's trade-offs for everything. And so these frontier models are very, very capable, but I think like where we can discern, what good looks like or what good smells like in domains where the answers are not as easily accessible, there's still a lot of work to be done. And again, like that's why Metabot scale AI, for example, right? That whole business is like paying experts in fields to effectively like generate data to be used in the entire pre-training step. So yeah, sorry, it's not like a
Thanks a
silver
lot.
bullet answer, but yeah,
Well, it was helpful. Thanks.
yeah. Cool. All right. Well, we're 20 minutes over. This has been fun. Thank you, everyone.
Thank
And
you.
thanks for coming, Rahul. It's been fun too. Hope to see you in the next one.
Thank you so much. Bye-bye.
Bye bye.
Bye, everyone.